students, welcome back. Let us begin the second part of the lesson in which you will learn the Scheffe test and its application. Scheffe test is a multiple comparison test which is named after the American statistician Henry Scheffe. This test compares the means of treatment either pairwise or non-pairwise. Pairwise means when we are comparing 1 with 2 or 1 with 3 or 2 with 3. So, this sort of comparison is called as pairwise comparison. Non-pairwise comparison means we are comparing one with the combination of the other two, that is 1 versus the average of 2 and 3, 2 versus the average of 1 and 3, 3 versus average of 1 and 2. So, this sort of comparing the groups is called non-pairwise comparisons. It is not necessary that you should involve non-pairwise comparison always. If any of the group is a control group means a group which is receiving no treatment or standard treatment or existing treatment is called a control group. Then it is enough to compare the control group versus an average of the other two. For example, in this group, suppose we have assumed 1 to be a control group, then it is enough to make comparison between 1 versus the average of 2 and 3. The other two non-pairwise comparisons you can skip. Let us understand Scheffe test by step procedure. The first step is you have to specify the level of significance which is similar to the one-way ANOVA. Suppose in your one-way ANOVA you have specified the level of significance as 5%, then you have to fix the level of significance as 0.05. In the second step, we will be finding out the mean differences of all possible pairs denoted by Lj. So, here J runs from 1 to 3 because we had 3 treatment to be compared. So, we have 3 comparisons, 1 with 2, 1 with 3 and 2 with 3. So, J is running from 1 to 3. When you had 3 groups, we are going to compare L1 as y1 bar minus y2 bar, L2 as y1 bar minus y3 bar, L3 as y2 bar minus y3 bar. And the next non-pairwise comparison, we are going to take L4 as y1 bar minus average is turned out to be 0.5 in this. So, it is 0.5 multiplied by y2 bar minus 0.5 into y3 bar. Similarly, L5 and L6 have been computed based on the average of y1 and y3, y1 and y2. After we have computed step 2, we are going to re-inspect what is the ANOVA table what we have performed in the overall ANOVA. So, this is the table. As I said, you are going to draw some of the information from this ANOVA table. So, after you find out the differences L1, L2, L3 so on up to L6, you are going to find out the critical value using the given formula. So, the critical value is acronymed as CV. CVI means suppose if you are finding out the critical value for the first comparison L1, so it should be represented as CV1. Suppose if you are finding out the critical value for the sixth comparison, then we will write CV6. So, here I represent the critical value for the corresponding comparisons. So, CV is nothing but the critical value for the comparison Li. K minus 1 and N minus 1 are between and within group degrees of freedom. Cj is the coefficient for treatment J in the comparison Li. Nj is nothing but the sample size of the jth group. We shall compute the mean differences L1, L2 so on up to L6 based on the formula given in the previous slide. So, L1 is nothing but the difference of the first group mean and the second group mean, that is 25.6 and 44.6, we will get 18.8. Similarly, we will find out all mean differences from L1 to L6. So, here I wanted to mention that, so in the previous formula I have mentioned something like coefficient of the treatment J. So, here we will look at what is the coefficient for the treatment J in the ith comparison. So, in L1, so the coefficient of the treatment 1 is 1 and the coefficient for treatment 2 is minus 1. So, we are going to take this value as our input for Cj. So, we have already performed one way ANOVA, there the result is found to be significant. Now, we further proceed to know which pair of mean is different using Scheffe's test. So, here the research question for comparing the first two group is whether the mean anxiety score of storytelling group differ from the musical audio group. The hypothesis to be compared here is H naught mu1 equal to mu2 against H1 mu1 not equal to mu2. So, we have to find out the critical value for L1 using the formula given in the previous slide, which is CV1. So, we are going to find the critical value for the first comparison L1, which is the comparison between first group and second group, that is y1 bar minus y2 bar. So, here as we mentioned 2 is nothing but our k minus 1. So, we have 3 comparisons. So, 3 minus 1 will be 2 and a 3.89 is nothing but the critical value coming from the F table. 82.5 is nothing but the mean sum of squares of error coming from the ANOVA table, and this is the coefficient which I am talking about. This is the coefficient of the first treatment, I was mentioning it as 1, and in the second one it is minus 1. When we square it, it is going to be plus 1. So, we have put its plus 1. So, all this put together calculates to 16.02. So, similarly, we will further proceed to the CV calculation for all the comparisons. CV2, CV3. So, CV2 is calculated in the same way. So, the value is 16.02. CV3 is also 16.02 because the size of the group is not changing. Suppose we had a difference in the size of the group, we may get a different answer for all these CVs. So, we will calculate CV4, CV5 and CV6. Here we have got a different answer because we have added the average of the other two groups. So, that is 1 by 5, 1 is a coefficient of the first group in the first comparison. Here this is the coefficient of the second treatment in the first comparison. Like that we get 3 terms, so that we are getting 3 different terms. So, which will end up with 13.87. So, with all this computation, we now proceed to present in a tabular form. So, what are the comparisons we have made? So, all the comparisons 1 versus 2, 1 versus 3, 2 versus 3 and 1 versus the average of 2 and 3, 2 versus the average of 1 and 3, 3 versus the average of 1 and 2. So, this is the corresponding differences we got, and this is the critical value which we have calculated. Now, we are going to compare these values as we did in the previous 2 case test. So, if this mean difference is more than the critical value, then we are going to reject it, otherwise we are not going to reject it. So, 18.8 is more than 16.2. So, we are going to reject it. Rejection of null hypothesis means we are saying the conclusion is significant. Similarly, here it is not more than CV. So, we are saying it is not significant. The third group is significant result, the other 3 we are getting non-significant. Based on the table, we are coming to the actual reporting of the Scheffe's test. So, here we had the different comparisons: storytelling versus musical audio, storytelling versus audio visual, musical audio versus audio visual, and these are the mean and standard deviation of the corresponding groups. So, this is the p-value which we get from the statistical package like SPSS. So, previously we had concluded based on the critical value. So, from the p-value we have understood it is less than 0.05. So, we are going to reject the hypothesis that the mean of the storytelling group is different from the mean of the musical audio group. Similarly, in this test all the means we are comparing are giving significant results. From the above table, we write the conclusion in the manner: the result of Scheffe's multiple comparison test performed for anxiety score among the 3 pain management techniques are presented in table 4. It was found that there was a significant difference in the mean anxiety score between the storytelling and musical audio group, musical audio and audio visual group, and there was no significant difference between the storytelling and audio visual group. particular video, we have discussed how to do multiple comparison test using Scheffe's test when your overall one-way ANOVA is significant. We have narrated the steps of Scheffe's test with an example of ANSYT data. I hope the concepts are clear to you. We will continue in the next video. Thank you.